Hello everyone and welcome back to my YouTube channel. In today's video, we are having a look at the mid-semester examination question paper for applied mathematics. This question paper was asked at the SIS Graduate School of Technology and it was for the first year engineering students or the FY Tech. If you will have a look, the duration of the paper is 1 hour and it carries a maximum of 20 marks. Now let us have a look at the structure of the question paper. So we have 3 questions in all. Question number 1. All questions carry equal marks and it has a weightage of 10 marks, and you can see that there are 5 questions, so each question carries 2 marks. In question number 2, it has a weightage of 5 marks and there are 2 problems and we got to solve either of them, A or B. Whereas question number 3, again it has 2 sub questions, A and B, and we got to solve any one, and it has a weightage of 5 marks again. So this paper was scheduled for a duration of 1 hour and I'll be solving this paper, and we will try and see that whether 60 minutes are really necessary for this examination. And also, if you have prepared well and you are thorough with the concepts and ideas and practice a lot of numerical, then this paper is really a cakewalk. So without any delay, let's get started. So we will be first starting with question number 1, A part. So if you have a look at the question, then it says that test the consistency of the equations, and we are given 3 equations in all. Now the very first thing which you as a student while attempting the examination should take care of is read the question thoroughly and understand what is the objective or the purpose of that question. So in this question we are given a 3x3 system and we are expected to test the consistency. So let's see this. First of all, let me write down the equations. The equations are these. I'm going to keep this video in 1x so that we can actually understand that how much time it is going to take to write down a detailed and nice solution for all the questions. So if any point in time you feel like it's going slow for you, you can get it done in 2x and fast forward the video. So we have the 3x3 system now. Now to test the consistency, we are going to take help of the system of equations written in matrix form. So first of all, let us rewrite the system in matrix form. And in this case, we are going to use augmented matrices. So A augmented B in this case is going to be the coefficients of the variables in all the 3 equations are going to constitute the coefficient matrix. So thus we have 1 1 1 as the first row, 1 2 3 second row, and 1 4 9 to be the third row. So we have here 1 1 1 1 2 3 1 4 9, and then we have a separator here, and then the constant part, which is 3 4 and 6. Now for the second step, we are going to reduce the given matrix into its row echelon form, into one of its row echelon form. So for that, we are going to consider this as the pivot element, and below that we got to convert the element or reduce them to 0. So in R2 we perform R2 minus R1, and in R3 as well we perform R3 minus R1, and as a result of this, A augmented B reduces to the first row remains as it is. Then over here we have 1 minus 1, that is going to be 0, 2 minus 1, which is 1, 3 minus 1, 2, and 4 minus 3, 1, and in R3 we have this. Now let's look at the next row, next column. This is the pivot element, and below this we have a 3 which needs to be converted or reduced to 0. So it's in R3. Now the silliest mistake which students make is, they use this 1, that means row 1, to make the entry 3 as 0, so which is absolutely incorrect. So you got to use the pivot element only. So we are going to use R2, and for that we are going to multiply R2 by 3. So once we have this, the augmented matrix A, B will reduce to the first and second row remains unaffected. The second row is going to be unaffected, while the third row changes. So we have got 0, then this is going to be 3 minus 3, 0, 8 minus 6, that's 2, and 3 minus 3, 0. And now if we have a look, so we have got 1, 2 and 3 pivot elements, and that exhausts the number of rows. So based on this, we are going to make further conclusions. So we'll say that the rank of A is going to be 3, and so is the rank of A augmented B. And also that happens to be equal to the number of unknowns. So since all the three quantities are equal, we are going to say that the given system is consistent and has unique solutions. So that's problem number 1 for you. Okay, now I just want to add a word of caution over here that you don't have to go a step further and find out the values of x, y, and z. That means you don't have to solve the system. Okay, now let's move on to question number B. In question number B, we are given a matrix A and we are asked to verify whether the matrix A is orthogonal. So let's get started with that. So firstly, let me write down the matrix A. It's 1 over 3 times we have entries as these. Now, before we go on for the solution, I will just add a note over here which you can incorporate in your solution. So, A is said to be orthogonal if and only if A times A transpose equals the identity matrix of the same order that of A. So, in this case, it should be 3 since matrix A has order 3 by 3. So as we see that we first will be needing the transpose of A. So let's write down A transpose. A transpose is also expressed sometimes as A raised to prime or A prime. So this is going to be 1 by 3. Now all the rows are going to be converted into columns. So we get this to be the transpose of A. Now secondly, we need the product of A with A transpose. So let's do that. So we'll say that consider A times A transpose. So firstly the matrix A over here times again 1 by 3 and we have the transpose of A. So here we are going to have now let's take the product. So firstly we have the two scalars over here 1 by 3 and 1 by 3, so that will give us the product as 1 by 9. Now the first row gets multiplied with the first column and we also take the sum simultaneously. So we have got 4 plus 1 plus 4. For this next entry it's going to be negative 4 plus 2 plus 2. For the third entry it's going to be negative 2 plus 4. Moving on to the second row entry, so this is going to be negative 4 plus 2 plus 2, and here we have 4 plus 4 plus 1, and here we have 2 minus 4 and plus 2, and in the last row we have got negative 2 and 4, then we have 2 minus 4 plus 2, and lastly we have got 1 plus 4 plus 4. So this is equal to 1 over 9, and you can see that this entry is 9. Now over here minus 4 plus 2 and plus 2, so this reduces to 0. Same thing happens over here and here, here, here and here. So all these entries are going to get reduced to 0, whereas only the diagonal entry, so this is 9, 9 and 9. So thus we have got the matrix entries as 9, 0, 0, 0, 9, 0, 0, 0, 9, and that is equal to I3. So since we started with A times A transpose and we have got that it is equal to the identity matrix of order 3, we can write down our conclusion. Therefore, A is an orthogonal matrix. Now let's move on to problem C. Now problem C, D and E, they are based on module 2, which is complex numbers, hyperbolic functions and logarithms of complex number. So let's start with C. So in C, it's now you are given a piece of data, which is that tan hyperbolic of x equals half, and they are expecting us to find out the value of sine hyperbolic of 2x. So using this given information, we got to figure out what is the value of sine hyperbolic of 2x. So we'll start with the definition. Now, of course, there are more than one ways to do this problem. We'll stick with the very elementary one. So we'll start with the definition of tan hyperbolic of x. So we know that tan hyperbolic of x, by definition, it is equal to e raised to x minus e raised to minus x divided by e raised to x plus e raised to minus x. And further, this is equal to 1 by 2. Now we'll be working with the middle term and the last term. So on cross multiplying, we will get 2 times e raised to x minus 2 times e raised to negative x is equal to e raised to x plus e raised to negative x. And we can see that these terms could be taken together. This also, so we have got this equals 0. Now, since we have a negative exponent, that negative exponent can be written as reciprocal by the laws of indices, and therefore we get e raised to 2x minus 3 is equal to 0, and further we get e raised to 2x is equal to 3. Now, if this problem is totally new to you, then you will go a step ahead and you will start figuring out what x is going to be using the last equation. But those who have already practiced and seen the lecture notes, for them it might not be difficult to realize that over here we have the angle to be 2x, and since the angle is 2x, means by definition of sine hyperbolic, it is going to be e raised to 2x minus e raised to minus 2x upon 2. So you see that this term is already evaluated over here. So we don't have to go further and find out the value of x. So using this, we'll move on further. So therefore, sine hyperbolic of x, which is given as sine hyperbolic of 2x, which is given as e raised to 2x minus e raised to minus 2x upon 2. This can be evaluated as 3 minus now e raised to minus 2x. Again, it's going to be the reciprocal. So this is going to be 1 over 3 divided by 2. Now simplifying the numerator, we are going to get 8 by 3 over 2, and this is reducing to 8 over 6, which is ultimately 4 by 3. Thus, this is the final value which we are looking out for. So that's how you do question C. Now let's move on to the D part. So in D part, we are given an expression and we are asked to calculate the value or evaluate this. So the expression is 1 plus I root 3 power 8 plus 1 minus I root 3 power 8. Now if you will have a closer look, then you will observe that both the complex numbers are conjugates of each other. So we'll be focusing merely on the first conjugate number, which is with the positive sign, of course. So consider 1 plus I root 3. So over here, we can evaluate r, which is going to be square root of 1 square plus root of 3 square, and this is going to be plus 2, whereas theta, which is evaluated as tan inverse of y by x, so that is going to be tan inverse of root of 3 over 1. So since it's root 3 alone, it is going to be pi by 3 or 60 degrees. So therefore, 1 plus I root 3 in polar form can be written as 2 times cos of pi by 3 plus I times sine of pi by 3. And similarly, if I talk about its complex conjugate, is going to be 2 times cos of pi by 3 minus I times sine of pi by 3. Now we'll move on further towards developing the given expression. So therefore, 1 plus I root 3 8th power plus 1 minus I root 3 8th power can be written as, so this is 1 plus I root 3. So we'll have 2 raised to 8 cos pi by 3 plus I times sine of pi by 3 raised to 8 plus again 2 power 8 cos pi by 3 minus I sine of pi by 3 raised to 8. Now we can see that 2 raised to 8 can be taken common, and also by the application of the Moivre's theorem, the power 8 gets multiplied to the argument of your trigonometric ratios in both the expressions. So thus we have here cos of 8 pi by 3 plus I times sine of 8 pi by 3 plus cos of 8 pi by 3 minus I times sine of 8 pi by 3. And we can get rid of the imaginary section. Thus we only have 2 raised to 8, and since both the terms are same, this is going to be 2 times of cos of 8 pi by 3. So that's 2 raised to 9, and cos of 8 pi by 3 happens to be negative half. So this becomes negative 2 power 8. You can leave it like this, or you can simplify the power of 2 raised to 8. So that's question D for you. Now let's look out for the last sub question in question 1, that is E. So again, we are given an expression and we are told to evaluate the value of that, and the expression is tan hyperbolic of log 11 plus tan hyperbolic of log root of 13. I'm sorry, this is log of root 11. So again, we are going to use the definition of tan hyperbolic. So this is going to be e raised to x, and instead of x we have got log of root 11. So root 11 then minus e raised to minus log of root 11 divided by e raised to log of root 11 plus e raised to minus log of root 11. And similarly for this, for the second term, we will be having e raised to log of root 13 minus e raised to minus log of root 13 divided by e raised to log of root 13 plus e raised to minus log of root 13. Now using a basic rule of exponents and indices, we know that e raised to log of x is x. So the first term will become root of 11. We can adjust this negative power and put it as root 11 inverse. So this is going to be minus root 11 inverse, which is nothing but 1 over root 11. So this is going to be 1 over root 11. Same thing in the denominator, root of 11 plus 1 over root of 11. And then we have got here e raised to log of root 13. So that will reduce to root of 13 minus 1 over root 13 divided by root of 13 plus 1 over root of 13. So this simplifying the numerator, we will be getting 11 minus 1, and we will have the denominator to be root 11, and in the denominator also we will have a denominator which is root 11, so we can get rid of that. So here we will have only 11 plus 1, and likewise this is going to be 13 minus 1 over 13 plus 1. So this is 10 over 12 plus 12 over 14. We can write down in its simplest form. So this is 5 by 6 plus 6 by 7, and a little cross multiplication will give us this, and we end up with 71 over 42. So that's the final answer for sub question. So you can have a quick check at how much time we have taken for performing all these 5 problems, and also not to mention that I am also simultaneously giving the details. So I'll be consuming definitely more problems. So if you are very thorough with the topics and problem solving strategies, then this should be taking you lesser amount of time. Now let's move on to question number 2. Now in question number 2, we'll be dealing with the A problem. So we are having the question as solve x raised to 5 equal to 1 plus I, and once we solve it we will be getting 5 roots since it's a degree 5 equation, and then further it is said that you need to calculate the continued product of the roots. So first let us solve this equation. So consider the equation x raised to 5 is equal to 1 plus I. Now the first part, what we are going to do is we are going to focus on the complex value, which is 1 plus I. So for 1 plus I, the R value or the modulus value is going to be square root of 2, whereas the theta value, it's going to be tan inverse of 1 over 1, and that turns out to be pi by 4. So therefore I can say that x raised to 5 is equal to square root of 2 into cos of pi by 4 plus I times sine of pi by 4. And this is the polar representation of the complex number 1 plus I. Further, since we are looking to solve this equation, what we are going to do is a default step, and that default step is adding 2n pi in the argument of your trigonometric ratios. So I have got here 2n pi plus pi by 4 plus I times sine of 2n pi plus pi by 4. Okay, and of course you got to specify what n is, so where n takes the value 0, 1, 2, 3 and 4. Now once we are done with that, we are going to talk about x alone. I have a look that this is x raised to 5, so now I'll be looking out only for x. That means I got to move the power 5 on the right, so this is going to be root of 2 raised to 1 by 5 into cos of 2n pi plus pi by 4 plus I times sine of 2n pi plus pi by 4, and this entire expression is raised to 1 by 5. Now for the first part, the first factor root 2 raised to 1 by 5, we can rework on root 2 and write it as 2 raised to half, and then 2 raised to half raised to 1 by 5 becomes 2 raised to 1 over 10. Now also let us simplify the angles over here. So this is going to be cos of 8n pi plus pi, and we can factor out the pi again. So this is going to be cos of 8n plus 1 into pi by 4, and the same angle will be coming here, 8n plus 1 pi by 4, everything raised to 1 by 5. Now at this stage we are going to take help of the Moivre's theorem again. So the power n we are going to multiply in the argument. So this is 2 raised to 1 by 10 cos of 8n plus 1. We have got here pi over 20 plus I times sine of 8n plus 1 pi over 20. Now recall the range of n. These values of n are going to give us the 5 roots. So when you put n equal to 0, we get the first root, let's call it as x0. So x0 is going to be 2 raised to 1 by 10. We are going to substitute the value of n over here. So this reduces to cos of pi by 20 plus I times sine of pi by 20. For n equal to 1, we will be getting the next root. So this is going to be again 2 raised to 1 over 10 cos of, now when you put n equal to 1, this 8n plus 1 becomes 9. So we have got 9 pi over 20 plus I times sine of 9 pi over 20. n equal to 2 gives us x2 equal to x raised to, I'm sorry, it's not x raised to, it's 2 raised to, and over here we will get 17 pi over 20 plus I times sine of 17 pi over 20. N equal to 3 gives us next root, which is x3, 2 raised to 1 over 10 cos of 25 pi over 20 plus I times sine of 25 pi over 20. And lastly, if you substitute n equals 4, you get the last root, which is x4, 2 raised to 1 by 10 cos of 33 pi over 20 plus I times sine of 33 pi over 20. So these are the 5 roots that we are looking out for. And further, if you will have a glance at the question, then they have also asked us to calculate the continued product of the roots. The continued product of the roots is denoted by capital Pi of xn, where n ranges from 0 up to 4. Capital Pi denotes the product, like we have sigma denoting the additions. So this is going to be x0 times x1 times x2 times x3 times x4. Now this is going to be, now if you will have a look at the at the r value, then the r value is constant across all 5 roots. So we will have 2 raised to 1 by 10 raised to 5, since it's going to be multiplied 5 times. And then for the next part, it is going to be cos of it's going to be this polar form multiplied by this, and this. And the easier way to do this is, first find out an angle, call it phi, and take the sum of all the arguments. So it's going to be pi over 20 plus 9 pi over 20 plus 17 pi over 20 plus 25 pi over 20 plus 33 pi over 20. So I'll say that the continued product of the roots is 2 raised to 1 by 10 raised to pi into cos of pi plus I times sine of phi, where phi is this, and this sums up to 85 pi over 20. So therefore the continuous products of the roots is equal to, now using the laws of indices, this is going to be 2 raised to half, which is root 2, into cos of 85 pi by 20 plus I times sine of 85 pi over 20. To cos of pi by 4 plus I times sine of pi by 4. So it's easy to identify that 85 over 20 can be written as 80 over 20 plus 5 over 20. So that's going to be 4 plus 1 by 4. And of course you can add the values of pi there. And since these are standard values, we get root 2 1 by root 2 plus I over root 2. From the denominator, you can factor out the root 2, which goes away with the root 2 outside the bracket, and we are left out with 1 plus I. So this is the continued product of the roots of the given equation. Now we will be further going on to solve on to question number 3a. Now in 3a, we are given a matrix which is of order 3 by 4, 3 rows and 4 columns. They have specifically told to reduce the given matrix to its normal form and also find its rank. So first of all, we will be moving on to reduce the matrix to its normal form. And once we have the matrix in its normal form, it's very easy to find out its rank. It comes merely by having a look at it. So let's start. So we are given the matrix A as this. Always after copying the question, the details of the question or the data, please ensure that you double check whether you have written correctly. Because if suppose say you miswrite any number over here, then everything goes wrong and all your efforts will not give you any marks. So we have got 1 3 4 3 3 9 12 9 and 1 3 4 0. So it is reducing the given matrix to its normal form, and further we are going to find out its rank. So firstly, you can see that we already have a 1 here. So let's use this one to reduce these entries to 0. So that we are going to perform EROs R2 minus 3 times of R1 and R3 minus R1. So we will have A simplified like this. The first row is unaffected. Now when we perform this, we are multiplying R1 by 3. So we get 3 minus 3 0, then 9 minus 9 0, 12 minus 4 3 is 12, again 0, 9 minus 9 0. Then while performing R3 minus R1, it's 0, then 3 minus 3 0, 4 minus 4 0, 0 minus 3 minus 3. So your first column is set. Now let's move on to the first row. So the first row, these entries need to be converted to zeros. Since these are row entries, we'll be using column operations for C2, C3 and C4. So for C2 we will use C2 minus 3 times of C1. For C3 we will use C3 minus 4 times of C1, and for C4, C4 minus 3 times of C1. So now your first column is unaffected. Now the other two entries in column 1, if you will see 0, so the subsequent entries of these rows will also remain unchanged. So we just need to focus on the first row entries. So we'll have 3 minus 3, that's 0. Then we'll have 4 minus 4 again, so this is 0. And lastly we will have 3 minus 3 again, so we have got 0, 0, negative 3. Now once we are done with that, you can see the first column and the first row is set up now. Now you no longer have any zeros in the second row, but in the third row we have a 0 in the last column. So we are going to perform 3 operations on this. So the 3 operations are going to move this number to this position and also reduce the number to 1. So since it's negative 3, I can either use a row operation or a column operation. So R3 divided by negative 3. So after performing this, we will get A as 1 0 0 0 0 0 0 0 0 0 0 1. So we have converted that negative 3 to 1. Now next we are going to move it to this position, the second row, second column entry. So for this we are going to perform row exchange and column exchange. So let's first perform R23, which exchanges the second row with the third row. So doing this, we'll get A as 1 0 0 0 0 0 0 1 0 0 0 0. Lastly, we will swap column 2 with 4 by performing C to 4, and this gives us that A is 1 0 0 0 1 0 0 0 0 0 0 0, and that's all. And for the final step, we will say that this is equal to I2. Now a word of caution over here, you can see that we are having 4 blocks which are created here. So in normal form, you denote all these 4 blocks by 4 letters. So of course this is the identity matrix. Then the next block on the right is a 2 by 2 0 matrix, so we will denote it by O. Then coming down, the third row part, this is again a block matrix of 0, and it's like this. So many a times it happens that student write it like this, so which is not the correct way to write down, and this will cost you marks. Okay, so this is the normal form which we have got. Now once we are having the normal form, the order of the identity matrix is going to give us the rank of the given matrix. And since the identity matrix is of order 2, we can conclude that rank of A is equal to 2. So if you do all of these things patiently and with a little presence of mind, then you might not require a lot of time and you'll be able to do the problems effortlessly. So I hope that this video, you will take in a lot of insights and certain pieces of advice which will help you in solving your examinations. And just one thing, like, means read the problem and do what is asked. Don't go beyond and try doing something extra. For two reasons. One, it shows that you have not understood the problem. And second, if you do something incorrect, then that might not look good in the evaluation scheme. Thank you so much for watching till the end. And if you have not yet subscribed to my channel, please do consider subscribing and also press the bell icon to get notified for the future videos which I'll be posting up soon. Thank you so much once again and happy learning.